Here's a quick rundown of parts A and B from question 1 on the 2022 Level 2 Physics Electromagnetism paper. So we've got two parallel plates set up 2.2 millimeters apart with 15 volts between them. And we're asked to show that the electric field strength between the plates is 6.8 times 10 to the 3 volts per meter. We're going to use the guess method to solve this one. And so our given values are the distance, which we divide by 1,000 to turn millimeters into meters, and the voltage. Our unknown in this case will be the electric field strength, so we're pretending we don't know that one, even though we've been given it in the question. And then we need to find an equation, and the resource booklet will give us E equals V over D. We can then substitute and solve, and I've rounded my answer to 2 significant figures because all of the values in the question were 2 significant figures. Next up, we're looking at an electron that is at rest initially, and it's accelerating towards the positive plate. And we're asked to calculate the maximum speed of the electron when it reaches the positive plate. This is a classic style of question that you might see, and it fundamentally requires you to equate the change in electrical potential energy with the gain in kinetic energy of the charge. And so we can use a formula to work out the change in electrical potential energy. So the electric field strength times the charge, Q, times the distance that charge has moved. So those are our values in there. The charge on an electron could be listed as negative 1.6 times 10 to the negative 19, but that value is given to you in the resource booklet, so you can just put in the value there. That's going to give us an answer of around about 2.39 times 10 to the negative 18 joules. I've rounded my answer just so it's easier to read on the screen, but if I was doing this in an exam, I probably wouldn't round until the final step in my answer. So then we know that the change in electrical potential energy is this much, and so we can say that whatever kinetic energy has been gained is also this much. We know that EK equals half mv squared, and we can rearrange that to V is equal to the square root of 2ek over m. We can then substitute in our values, and the mass of an electron is given in the resource booklet, 9.11 times 10 to the negative 31. And so substituting those values in, being careful with our brackets there, is going to give us an answer of 2.3 times 10 to the 7 meters per second, again to 2 significant figures.